Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Aqre 1 by Tuberculosis, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. All odd numbers must form one single connected group, and numbers must share an edge of a cell to be connected. Diagonals do not count. So that means all the odd numbers in this puzzle is going to be able to form one single connected group. So that means you can go from any odd digit in this puzzle to any other odd digit in this puzzle just by going through edges, all while staying within the odd cell region. There can be no more than 4 consecutive odd numbers in any row or column. That means you can only have at most 4 consecutive odd digits. So what we could have is something like, say, 3, 1, 5, 9. Here, you cannot have a 7 here, because that would be 5 consecutive digits in a row or column. And we do not have more than 4 consecutive odd numbers in any row or column. I think I would have preferred this saying there can never be 5 consecutive odd numbers in any row or column, because that's very clear, right? You can't have more than 5 because there's only 5 odd digits per row and column, but I think you can get easily confused by there could be no more than 4. Granted, it is very clear what that rule is, but I don't know. I just can't when I see that, I just see there can't be 4 consecutive odd digits. And that's just the way I see it. So that I would prefer it if there cannot be 5 consecutive odd digits, because that's very distinctly clear about what that is. Versus there can be no more than 4. I don't really know why we have to have that particular um, specification there, I guess. Anyways, so this is not allowed here, but having just the 4 by themselves is allowed. There can also not be a 2 by 2 group of odd numbers. So you couldn't have something well, say we had something like this. We could not have a 1 here, right? Because then this 2 by 2 area would be all odd numbers, which is not allowed in this puzzle. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, let's start by marking all the digits as odd or even. That actually gives us some information. Where is the 1 in column 5? Cannot be here because 1's in the boxes. Can't be here because 1 in the row, so 1 has to be here. We don't have very much information there. We don't have much information. Oh, where's 1 in row 2 then? Cannot be here because 1's in the boxes, so 1 has to be there. And that's odd. 2 has to be one of these 2. Cannot be here, so it's one of those 2. Yeah, okay. 3 has to be one of these 3. 4, we don't really have any information. 5, okay, so 4 has to be even. 5 has to be odd. 6's. 6's in column 5 obviously has to be one of those 3. And in row 3 has to be one of those 3. Those are all even. 7. 7 in this upper left-hand box has to be one of these 2 digits here. And in this right central box, cannot be here because of 7 in the column, 7 in the row. So 7 is one of those two, and these are odd. 8. 8 in row 6 cannot be here because of 8's in the boxes, can't be here because of 8 in the column, so 8 has to be here, which is even, which means where's the 2 in column 3, it has to be here. So that's 2. 8 in column 1 has to be one of those two because of 8's in the boxes there. 8 in column 6 cannot be here because of 8 in the boxes, can't be here because of 8 in the row, so 8 has to be here and is even, which means one of these two digits is 8 for the 8 in row 9. Okay, and these are all even. Then we have 9s. Those are both odd. Where is the 9 in row 6? Cannot be here because of 9's in the boxes, so 9 has to be there. And we have that information. 2 has to be one of these 3. Okay. All the red cells must be orthogonally connected. So this has to be red because if that were blue, it would not be orthogonally connected to the rest of the red cells. Now we have a 2x2 area that has 3 reds in it, so it must have a blue. This has to orthogonally connect, so it must be connecting there. We have 4 evens in row 2, so the rest are odd. This is a 2x2 area that's all odd, so this can't be odd here, it's even. Okay. This is 2 or 8 here. This can't be 1, 3, 7 or 9 because of 1, 3, 7 in the box and 9 in the column, so that's 5 there. That means 9 has to be one of these two digits. We already have 1, 3, 5, 7 accounted for in this upper right-hand box, so this can't be 1, 3, 5, 7 or 9, so it's therefore even. The red has to orthogonally connect. It can't do it through this way. It has to go this way. And we have 2 more evens in row 1. This can't be even because then one of these would be odd and would not orthogonally connect to the other odd cells. So therefore this must be odd with 2 evens here. That eliminates evens in the rest of this upper left-hand box, so this must be odd, which means this can't be 8. So 8 has to be here, which makes this 2. That leaves 8 as one of these two digits in row 3, and this must be a 6, 8, 9 triplet. No 9 there, no 8 there. This is 4 as the last even digit in row 1. We have 4 even digits in column 2, so that means the rest of the digits are odd. This is a 2x2 area that is all red, except for this one, which means that's blue. This is a 2x2 area that's all red, and it's 3 reds, so this must be blue there. That gives us 4 blues in this left central box, so this must be even, or sorry, not even, that's odd. Remaining digits. In row 1, we have 3 and 9. Remaining digits in row 2, we have 5, 7, 9. And this can't be 5, so it's 7 or 9. This can't be 9 because of 9 in the column, so it's 5, 7. This could be any of them, 5, 7, 9. We know 9 has to be one of these two digits because we have a 6, 8, 9 triplet in row 3. So these cannot be, it can't be 1, 2, 4, 6, or 8. So we have 3, 5, and 7. No 9 available here. 7 can't be here because of 7 in the column. This, we have 4 even digits in column 1, so the rest must be odd. That leaves this as a 4-6 pair. And we have to have a 1 somewhere here. So 1 has to be one of these two digits here. We have 1, 3, 5, and 9 as possibilities. Obviously no 1 there. 9 has to be one of these 3. We have 1, 3, and 5 remaining here. 3 can't be here because of 3 in the row, so where's 3 in this left central box? It must be there. This must be 1, 5 as a pair. 1 can't be here because of 1 in the column, so this is 5, which makes that 1. 5 eliminates 5 in the rest of column 3. We have a 7, 9 pair in row 2, which eliminates 7 and 9 in the rest of the row, so no 7 here. It's 5. Okay. We have 2 or 4 here. One of these digits is a 6, and this can't be a 6 because of 6 in the row, so 6 in this column has to be there, so that's even. Which means we have 4 evens in this lower left-hand box, so we need another odd. This must orthogonally connect to the rest of the odds, so that's odd. Okay. Remaining digits of row 3, we have 2, 3, 2, 3, 4, 5, or 7. And this can't be 2 or 5 because of 2 or 5 in the column. Okay. Three eliminates 3 here. What's left is a 5, 7 pair. We have 3, 7, 9 available in column 3. This has to be 3 or 7 in column 4. We have 2, 3, 4, 7 left in column 4. This can't be 4 because of 4 in the row. No 2 here because of 2 in the box. This is a 3, 4, 6, 7 quadruplet here. No 3 here, no 3 here. Because of 3's in the row. We have 4, 6, or 7 here available. We need a 1 in row 4. And it cannot be here because of 1's in the boxes. Can't be here because of 1 in the column. So 1 has to be here. That's odd. This is 4, 6, or 7 left. No 7's here because of 7's in the row. So that means where's the 7 in the central box? It must be one of these two cells. That eliminates 7 in the rest of the column. Where is 7 in this upper central box? It must be one of these two digits here. So this is one of these is 7, one of these is 7. That means one of these two is a 7. Okay. Remaining digits of this right central of row 6, actually, let's do that. It's 2, 3, 4, 5, and 6. But 3 and 5 cannot be here. Where's 5? And 5 has to be one of these two digits. No 2 here because of 2 in the column. No 4 here because of 4 in the column. One of these two is going to have to be odd to orthogonally connect. One of them has to be even, because if one of them is odd, that gives us 3 odd digits in this 2 by 2 area, so the other must be even. So this is an odd even pair. We don't have very much else there. The remaining digit in column 6, we have 3, 4, 7, 9 again. Um. hmm. Yeah. Um, one of these two digits must be even. So if this is even, this has to connect, well, yeah, this has to connect orthogonally to the odds. And it can only go either that way or this way, if this is even. If this is even, this must orthogonally connect to the rest of the odds. So either way, this is going to be odd. Hmm. One of these is a 7. So one's odd, the other is even. Hmm. Um, oh, 5 eliminates 5 in the rest of the box. So 5 has to be one of these 3 digits there. Um, one of these is odd, at least. Oh, these can't be 3 because of 3 in the box. So 3 is guaranteed to be one of those 2. Hmm. Um, hmm. Uh, Remaining digits in this lower central box, we have 2, 3, 4, 5, 7, 9. No 2 here because of 2 in the row. No 4 here because of 4 in the row. No 7 here because of 7, and it has to be one of those 2 digits. And this can't be 7 for the same reasoning. This is odd, so this cannot be 2 or 4. Where is 2 then in this central box? Or this lower central box? It has to be one of these 2 digits here, which means 2 cannot be here. 2 is one of these 2 digits there. Therefore, if this were 5, this would have to be 2, which would mean 2 can't be here. 2 would then have to be here, which is problematic because then this 5 would not be orthogonally connected. So this cannot be a 5, which means 5 has to be there. That's odd. This must be even because it can only be 2 or 6. This is even too. It's 2, 4, or 6. Um, hmm. Um, um, hmm. Remaining digits, row 7, 2, 3, 4, 5, 7, 9. Again, no 2, 3, or 5 there. No 3 or 5 there. No 4 or 7 there because of digits in the column. This can't be 9 either because of 9 in the column. 1 has to be one of these two. There's going to be odd digits in this lower right-hand box here. They're going to only orthogonally connect here to this cell here. We have a 2 by 2 area that has 3 odd digits, so this can't be odd, it's even, which makes this a 4, which means this can't be 4, it's 7 or 9. No 4 there. So one of these two was a 7 here. So this can't be 4 anymore. It's guaranteed to be odd then. And one of these is odd, the other is even as a 2. We have a 4 guaranteed in one of these two cells here. We have an 8 guaranteed in one of these two cells here for the 4-8 pair in row 9. And therefore, this has to be a 4-8 pair, and they must both be even. That gives us 4 evens in row 9, so this can't be even, it's odd. It has to orthogonally connect, so that's odd. We need a 1 somewhere in column 8. It can only be here now. So this is 1, which eliminates 1 here, which means this must be 1 there in column 1. One of these has to be orthogonally connected to connect the odd digits. So this can't be odd. This must be even. Cannot be 3, 5, or 9. It's 2, which makes this 7. Therefore, this is odd. We have a 2 by 2 area that's all odd, so this can't be odd. That's even. 7 eliminates 7 here, so it's 9, which eliminates 9 in the rest of the row. 9 eliminates 9 in the rest of the column. This cannot be 9, so it can't be odd anymore. This is an even pair. That forces us not to be even. That's odd because of a 6-8 pair. We eliminate 6 here, so that's 9. 7 eliminates 7 here. This must be even as a 4, 6. That leaves a 7 here. It's odd. This must be a 3, 5 pair here. That leaves this as a 6. There's only one place for that in the lower right-hand box. 6 eliminates 6 here, so that's 8 and 6. 8 eliminates 8 here, so it's 4 and 8. 6 eliminates 6 here, so it's 4. This can't be 4, 6, or 8, so it's 2, which makes that 6. 4 eliminates 4 here, so it's 6 and 4. This can't be 4, 6, it's 7, which is odd. That eliminates 4 and 7 there, so this is 6, which is even. We have to, since this is even here, this can't be even here because we have to orthogonally connect, so that's odd. We have 5 odds in this upper central box, so this can't be odd, it's even. So this is a 2, 4 pair. That eliminates 2, 4 in the rest of the column. This must orthogonally connect for the odd digits, so therefore this is odd. This is a 2 by 2 area that's all odd, so this can't be odd, that's even. Since this is even, we have 4 evens in column 4, so this can't be even, that's odd. And this has 5 odd digits here, so this can't be odd, it's even. Therefore, this is 2, that makes this 4, which makes that 2. This has to be 4. because it's even. This can't be 4, 6. It's 3, which eliminates 3 there, so it's 5. No 3 or 5 there. It's 9. No 2 here because of the even already in the box. Huh. 9 eliminates 9 here. It couldn't have been 9 anyways. It's 3 or 7. We have a 3-7 pair in row 9, which eliminates 3, 7 in the rest of the row. So this can't be 3. It's 5, which makes this 3. 3 eliminates 3 here, so it's 7 and 3. 3 eliminates 3 here, so it's 7. That eliminates 7 here, so it's 9, which makes this 3, which makes this 5, which makes that 7. 5 eliminates 5 there, so that's 3, which makes this 9. 7 eliminates 7 there, so it's 5. 7 eliminates 7 there, so that's 3, which makes this 9, which makes that a 7. And that's how you solve it. Fairly straightforward. I actually don't even know. Do you really even need there could be no more than 4 consecutive odd numbers in any row or column? I don't think I used that once at all in this puzzle. So I just, That's very strange that you would have that as a rule set because it's not necessary to solve this puzzle. Interesting. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.